All right, let's do a simple prism problem. We've got a right-angled glass prism, n equals 1.5. We have 45 degrees and 45 degrees, equilateral. And before we go anywhere, I'm going to tell you that we're going to calculate the critical angle. N equals 1 over sine of the critical angle. Critical angle for glass, because that's going to be 1.5, is 41.8 degrees. That's going to show up in just a second. Here comes the light ray. In this problem, it's coming straight in against that side. The incident angle is 0 degrees. Where do you think that light ray is going to go? It's just going to go straight through. It will not refract here. Now what's going to happen over here? Well, let's draw in a normal line. And we need to determine the angle right in here. We have to get that angle. Let's see how we do this. This is 90 degrees. This is 45. That means that's 45. That's a right triangle. If that's 45, this is 45. What's going to happen if that's 45 degrees? We're in the slow side here, the slow medium, trying to get out. But the critical angle is 41.8. You could try using Snell's law, you're going to get the error. That thing is going to reflect. Total internal reflection. Now the angle of incidence will be equal to the angle of reflection. That means this angle is also going to be 45 degrees. Well, if that's 45, that's 45, that's 45. Hey, I think I'm starting to see a pattern here. I'm going to draw in the normal line. And now I can tell you that this angle in here is also going to be 45, 45, 45. Where is the light ray going to go? It's again beyond the critical angle. It's going to reflect. Angle of incidence equals the angle of reflection. So this angle is going to be equal to that angle. 45, 45. Well, that means this is 45, that's 45. This is now going to be 90. It's going to come straight out. This is a great way to make a reflector, a mirror, out of a prism that has no mirrored coating. And this thing is used in optics, in telescopes, and in binoculars and periscopes, because it's an excellent reflector. All right, now for a much more challenging problem. Prism problem 2. We have the same glass, n equals 1.5, and we have an equilateral prism, 75 degrees, 75 degrees, and 30 degrees. The light ray is going to come in parallel to the horizontal at the bottom. I've drawn in the normal line, and we're just going to trace this ray through, and then we'll do the math. Where do you think this light ray is going to go? It can't go straight. It's going into the glass, which is slower. It's going to bend toward the normal and then strike the other side. Now what's going to happen from there? We have to put in the normal line. Whoops, wrong tool. That's about normal, huh? Now, that is less. Just by eyeballing this, this looks less than the 41.8 degrees for that critical angle. And I think we're going to see the light ray escape. If it escapes, is it going to bend toward or away from the normal? It's going into the fast side, so it should bend away from the normal. Now what we have to do is play with the numbers. If this is 75 degrees, the angle in here is going to also be 75 degrees. The angle from this brown line to the black line, that's 90 degrees. If that's 90, then the angle in here is going to be 15. We need to use Snell's law to calculate this angle right in here. Here comes the math. Snell's law, fast over the slow. We have 15 degrees in here. We have the refracted angle in here. And the index of refraction for the glass is 1.5. When I do the math, I get 9.94 degrees. I can't type it in here. I'm just drawing a line to tell you 9.94 degrees is right in there. Now, if that's 9.94 degrees, we eventually have to figure out what this angle is. How are we going to do that? We're going to walk around the triangle. This angle over here, that angle is going to be 80.06. Let's type that in here. 80.06. That's this angle. Now, if that's 80.06, I'm going to add 30 to that. Subtract 180, and I get 69.94 for this angle. This is a triangle. Angles add up to 180. So that angle is 69.94 degrees. How do I get this angle now? Well, that brown line is a normal line to this line. So you have to take 90 minus this. And we get 20.06. So I'll just go like this. Whoops. .06 degrees. And now we have to do the math again so that we can figure out what angle the light leaves the prism at. All right, so we start with the Snell's law again, sine I over sine R, but we have to remember it's fast over slow. So let's take a look at this. This is 20.06 degrees inside the glass, so that's going to go on the bottom. What's on top? That's what we're looking for. 1.5 is the index of refraction. We do the math, we get 30.96 degrees. Now, does that seem like it's the right kind of an answer? Well, it's bigger than this. It bent away from the normal. So this is basically the trend of the line, the ray.